expansion of sine to the fourth power, and we want to expand it in a way such that it doesn't have any powers at all, just single powers of sine. And we're going to use this identity, cosine of 2x equals 1 minus 2 sine squared x. We might not be able to get it down into a function of sine, but at least we can get rid of the exponent. So if we're going to use this identity, this is the cosine of the double angle identity, we're going to solve it for sine squared x. So first things first, I'm going to switch the places of cosine of 2x and 2 sine squared of x. So this one becomes negative and that one becomes positive. So we'll have 2 sine squared x is equal to 1 minus cosine of 2x. Divide everything by 2, and we'll have sine squared x is equal to 1 minus cosine of 2x over 2. And what I really should have done is use like a dummy variable like theta or something, not the variable we're using over here, but we'll deal with it. Alright, so the first thing is I'm going to rewrite this as sine squared x all squared. And that way we're not changing anything right now, we're just kind of separating one of the powers away. And where I see sine squared x, I'm going to replace it with this 1 minus cosine 2x over 2. So this will become 1 minus cosine of 2x all over 2 all squared. It's kind of messy with a fraction, so I'm going to get rid of this 2. I'm going to square it first, it becomes 4, and then I'm going to factor it out. If I factor it out, it becomes 1/4. And then what I have left over is 1 minus cosine of 2x all squared. If I expand that out, I'm going to get 1 minus 2 cosine of 2x plus cosine squared of 2x. Alright, now this still has a power in it. It's over here, cosine squared of 2x again. I'm going to have to use another identity to take care of this one. The other cosine of 2x identity that I'll need to use is the one with the cosine squared in it. So if I solve this one in terms of cosine squared, I'll add 1 to both sides, divide by 2. We'll get cosine squared x is equal to, and it's going to be adding 1 across, so I can write it either way using the commutative property. I'm going to write it as 1 plus cosine of 2x to keep it in the same type of form as the green one up here, all over 2. So I can replace this cosine squared of 2x with 1 plus cosine of 2x all over 2. Alright, so 1/4, 1 minus 2 cosine of 2x plus, and we'll put in here the 1 plus cosine. Now the angle's a little funny. This says cosine squared of 2x, this is just cosine squared of x. So if I take x, over here I have to double it. Here I'm going to be taking 2x in place of this x, so I'm going to have to double it again, so that's going to become 4x all over that 2. And we've removed all the powers, I just need to simplify some things. So if I kind of expand it out 1/4 through, we're going to get 1/4 minus 1/2 cosine of 2x. We're going to have a half here times a 4th, so it'll be plus an 1/8. Another half in front of this cosine times that 4th will be an 1/8 of cosine of 4x. And there's only one last thing that we need to do is combine like terms. We have an 1/8 and a 4th. Common denominator is an 1/8, so this would be 2/8, so that would be 3/8 minus 1/2 cosine of 2x plus 1/8 cosine of 4x. And this whole thing, this last little blue thing, is equal to sine to the 4th x. Now right now you're not going to see why we need to be able to do this, but whenever and if ever you get to calculus, working with sine to the 4th x is not viable, but working with all these little pieces over here to the left, it really is kind of simplistic. Even though it's longer, it actually makes it a lot easier.